Now let's look at how we can use logarithms to solve equations. So, first off, we know that we can take a logarithm and convert it to an exponential or vice versa. And that can be a great help to us in solving equations. Keep in mind, though, that we have to always make sure that our solution obeys the fact that the base must be positive and not equal to 1, and the argument of our logarithm can never be made negative by a solution. So we have log base 5 of x equals 4. If we convert this to an exponential, we would have the base of 5. The exponent on this would be 4, and this would equal x. So what is 5 to the 4th? 625. If we substitute this back in, notice it does not make the argument x negative or 0. So we're okay. Let's look at this one. Again, let's convert this to an exponential. The base is 2. The exponent will be on the other side, so 2 to the 6th equals 5x minus 1. 2 to the 6th is 64. So we have 64 equals 5x minus 1. So we have 65 is 5x. Divide both sides by 5. We have 13 equals x. If we check, notice 5 times 13 minus 1 is 64. That's not negative, so we're okay. Now, let's go ahead and try this one. We're going to solve this for x, so we will subtract 1 first from both sides. So let's write this as negative 1 plus log base 9 of 729, and that should equal negative 2x. Now I would be careful at this point. If you wrote it the other way, log base 9 of 729 and subtract 1, forget my base, that's okay. I would emphasize that this argument is 729. You take the log of that and then subtract 1. Now let's divide by negative 2. This is 1/2 minus 1/2 of log base 9 of 729 equals x. The main thing to remember here is that the 1/2, I'm not dividing 729 by 2. I'm taking the whole log and dividing by 2. Now let's try this one. So we have 5e to the 2x, subtract 1 equals 10. So we're trying to isolate x. So let's add 1 to both sides. So we have 5e to the 2x equals 11. Now let's divide everything by 5. So we have e to the 2x equals 11/5. Now let's convert this to a logarithm. The logarithm will be base e, and it will separate the base and the exponent. And so we have log base e of 11/5 equals 2x. Now, we don't write log base e. We write natural log. So we have natural log of 11/5 equals 2x. Divide both sides by 2. What do we get? We do not divide the 11/5 by 2. So we have 1/2 the natural log of 11/5 equals x. So we take the natural log and multiply by 1/2, or the natural log, and then divide by 2. So now let's take a look at this logarithm. So if we convert this to an exponential, we would have 2 raised to the third power equals our x squared minus 2x minus 7. So we have 8 equals x squared minus 2x minus 7. This is quadratic, so let's get one side equal to 0. This factors into x minus 5x plus 3. So this gives us x equals 5 or negative 3. Now, let's put in 5 and see what happens to our argument. We get 25 minus 10 minus 7, and that gives us 8, which is okay. Put in negative 3. 9 plus 6 minus 7. 9 plus 6 is 15, minus 7 is also 8, so we're okay. Again, we do not want an argument that is made 0 or something that's negative. If we go ahead and convert this logarithm into an exponential, we have x squared equals 81. We can take the square root of both sides. We get x equals positive or negative square root of 81. And so x equals positive or negative 9. But remember, what is x in this problem? It's the base. Our base of a logarithm can never be negative, and it can never equal 1. So our answer is simply x equals 9.